Hey guys, this is Mike Keenan. Today I'm going to go over IPv4 addresses. So IPv4 and then there's also IPv6. We're going to talk about IPv6 in a different video. So IPv4 addresses are going to be at the network layer of the OSI and TCP/IP models. They are required for IP networks, so every device that's on an IP network needs to have an IP address. If a device has an IP address and a network interface card, it is referred to as an IP host, or just host for short. There are over 4 billion total IPv4 addresses available for use. However, that number just isn't big enough for what we need. So what they've done is they've created a new IP addressing scheme known as IPv6. Another term to be familiar with IPv4 is a term called NAT. Network Address Translation. That's kind of the band-aid or the fix to IPv4 addresses, and we'll get into that in a separate video. So IPv4 addresses are 32 bits long. They are represented in dotted decimal notation. And what that means is that there are what's known as 4 octets in every IPv4 address. So I'm sure you've seen an IP address before, like 192.168.1.10. That's an IP address. Each one of these is known as an octet. Each one of these numbers, so there's 4 total. IPv6 addresses are 128 bits long, and they are represented in hexadecimal notation. Hexadecimal is different than dotted decimal in that there are letters included. So it goes 1 through 9, actually 0 through 9, and A through F. So 1, 2, 3, 4, and then once you get to the last digit, it turns into A, B, C, D, E, and F. Whereas IPv4 is 0 through 9. So here we are at the dreaded IPv4 classful addresses slide. Now there's no real easy way to do this, it's just straight memorization. So you're just going to have to memorize each one of these if you want to pass the CCNA certification. So class A is 1 through 126 for the first octet, and then any number that falls within that range is a class A unicast address. So then we have the reserved addresses here, which are anything that starts with 127 all the way up to 127.255.255.255, and you may recognize that 127 as being the loopback address. 127.0.0.1. Class B unicast addresses are 128 through 191.255. There are more than 16,000 possible networks and 65,534 possible hosts per network. And up here for Class A, you've got 126 possible networks and over 16 million possible hosts per network. Down here you have Class C unicast addresses. So those begin with 192 through 223.255.255.0. There are more than 2 million possible networks and 254 possible hosts per network. So as you can see, once you start from Class A, going to Class B, and going to Class C, the possible hosts per network decreases, whereas the possible networks increases. Class D, this is your multicast addresses. That's 224.0.0 through 239.255.255.255. And then lastly, you have your Class E, which are your reserved, also known as experimental addresses, which range from 240 to 255.255.255.255. And then you of course have your private IP addresses, and each class has its own private IP address range. And what private IP addresses are they are ranges of IP addresses that are freely available to use for any organization or any home. Any type of an entity can use any of these private IP addresses. They're private IP addresses, and if you wanted to know more, you can look them up in RFC 1918. You'll commonly hear private IP addresses be referred to as RFC 1918 addresses. You have Class A private addresses, so anything that begins with 10 is a Class A private address. There are 8 mask bits. Class B, anything that starts with 172.16 all the way through 172.31 is a Class B private address. The mask bits are 12 for Class B private addresses, and then you have Class C private addresses. Anything that starts with 192.168 is a Class C private address, and they have 16 mask bits. But what does all that mean? What are these private IP addresses versus public IP addresses versus classful IP addresses? What are they used for? Well, like I said before, every host on a network needs to have an IP address, and there's always going to be 2 different parts of the IP address. There's going to be the network portion, and then there's going to be the host portion. So IPv4 addresses in general are represented in a couple of different ways. They could be represented in binary notation and also in dotted decimal notation. So believe it or not, if you're not familiar with this already, this string of zeros and ones up here actually equals this number down here. 10.10.10.0 255.255.255.0 is represented by this long string of ones and zeros. This is how a computer sees it. This is how it looks when it runs over an IP network. This is just abstracted for us as humans to be able to understand and remember them better. So down here we have two different networks. We have the 10.1.1.0 network, as that's represented here by these first three octets of both these hosts, PC1 and PC2. PC1, the host address is 25. PC2, the host address is 26. So you can kind of think of this as being a street. So these two hosts here both live in the 10.1.1 network, or you can think of that as being the 10.1.1 street. And over here on this side, we have the 192.168.1 network, and this server is host 35 in that network. So if PC1 over here wanted to talk to PC2, he can do that directly because they're what are known as layer 2 adjacent. They're connected to each other over a switch. But say PC1 or PC2 wanted to communicate off of its local area network, so it wanted to communicate to something other than 10.1.1. something. Let's say they wanted to communicate with the server over here. Well, they would have to first communicate with what's known as their default gateway. And in this example, that's going to be this router here. And he'll most likely have an IP address of 10.1.1.1. And the host address for that interface is 10.1.1.1. So he would send the information to 10.1.1.1, which is his default gateway, and then the router would communicate over the internet to this other router over here. The router would then forward the packet over the wire to server 1. And of course, can you guess what this IP address here would be? It would probably be 192.168.1.1, with 1 being the host address. And briefly, we're going to talk about subnetting. Subnetting is the practice of taking a classful IP address such as 10.x.x.x and then subnetting it into a smaller or larger network. So in other words, you might be able to take it and make this a 10 over here, make this a 10, and that becomes his new subnet. Subnet being 10.10. and then this being the host addresses over here. So there you have it. That's IPv4 addresses in a nutshell. I hope you liked this video. I hope you learned something. Don't forget to like and subscribe, and I'll see you in the next one.